Good day. So this time we are going to recall the special right triangle, and that is the 45, 45, 90. So again, let me type it for you. 45, 45, 90. So this is a special right triangle. Okay. So let's recall the concept on this triangle. So here, well, say for example, this is your right triangle, and this is your right angle. This angle here measures 45, and since this is 45, and the right angle measures 90, so what's the measure of the third angle? So again, this is 45. Okay. Now, if you do remember, in our Pythagorean theorem, we discussed the different sides here. So this is our C, this, yeah, this could be our A, and this is our B. A and B can be interchanged, it's alright. It won't matter. While here, now as you can see, C is the opposite angle, or C is the opposite side of the largest angle, while B is the opposite side of the angle measures 45. Same thing also with A. A is the side which is opposite to your angle which measures 45 as well. Therefore, if we're going to check this out, so this triangle, okay, let me use another color. So say this triangle that measures, this is the right angle that measures 90, this is 45, okay, this is also 45, while this side is our C. Now if this is our A and RB also, and RB is the opposite side of exactly the same measures of the opposite angle of the side A. Therefore, this could be our A as well, right? Now, in our Pythagorean theorem, we've learned that this is C squared, sorry, this is C squared is equal to, sorry, A squared plus B squared. Now here, in our second triangle, RB becomes RA. Why? Because they are the sides which is opposite of the same measure of the angle. Therefore, in our Pythagorean theorem, originally which is c squared is equal to a squared plus b squared, this becomes c squared is equal to a squared plus a squared instead of b squared. So we will simplify this equation, we'll simplify this equation. So c squared is equal to 2 because we can surely combine this because they have the same literal coefficient. So this is c squared is equal to 2a squared. Now for us to find c then, so this is c squared is equal to 2a squared. So we will take the square root of each side. So square root of c squared, then square root of 2a squared. So this will be cancelled at the same time here, but of course your 2 should still remain inside the square root symbol. So this is now c is equal to a and the square root of 2, right? So that is how we're going to find our a, or our c rather. So what about how we're going to find our, how about finding our a? So Remember, we have then c squared. Okay, let's draw a line here. Okay, let's use another color. Okay, here. Now, say this is green. Okay. You have seen this is c squared is equal to 2a squared. So how we're going to find a? So we'll divide both sides by 2. So this is now c squared divided by 2 is equal to 2a squared divided by 2. So this time our 2 will be cancelled. What is left then is c squared over 2, which is equal to our a squared. Okay, so for us to find our a, so let's use, oh sorry, ouch, for a while I forgot it. So again. So let me type it for you. So this is now c squared over 2 is equal to a squared. So we are going to take the square root of each side. So the square root of c squared, okay, c squared over 2. Okay, so let's adjust this one. There you go. Which is equal to the square root of a squared, right? So this is the square root there, the square root of a squared. Okay, there you go. So we can cancel the exponent of c and a. Okay, but here as 2 in the denominator, still that is in a rational form. So, or in a radical form. So this is now a is equal to c over the square root of 2. Now since your denominator has radical, so we will rationalize the denominator. So we'll multiply the whole expression, or we'll multiply each term by the square root of 2. So c will be multiplied by the square root of 2, and of course the denominator square root of 2 will be multiplied by itself. That is the square root of 2. Okay, I could hardly type here or write here. There you go. So then a is equal to, alright, the square root of 2, okay, over 2 times c, whatever the length of your side c. Why is it 2? Because the square root of 2 times 2, this is the square root of 4, right? And the square root of 4 is 2. Now, we have the pattern in finding A. We also have the pattern in finding C. If this is a special right triangle, 45, 45, 90. So let's have an exercise here. Say for example, this is a 45, 45, 90 triangle. Say this is the right angle. Okay, there you go. While here, this is 45, sorry, so this is 45, here this is also 45. Let's say for example, one of the sides measures 10. Okay, obviously since these two segments or sides are congruent, so let me use another color. Say this is congruent, therefore this side here is 10 as well, right? Because they are equal. Therefore our unknown is our C. That is the third side or the longest side. So we will use, okay, we'll use this pattern. So then this is now C is equal to A, okay, A and the square root of 2. So let's enclose this with square root. So this is the square root of 2. How long is our A? So C then is equal to 10 and the square root of 2. Easy, right? Wow, so easy. So how about if we're going to have another triangle? Say here. Say for example, this is still 45, 45, 90. So here, this is 45. Okay. And this is your 90-degree angle. This is also 45. Now what if the given this time is the longest side? Say this is 20. Okay. So we're going to find the measure of one of the sides. Anyway, they are just same because they are congruent. So we will use this pattern. Okay. So we're going to find A. So then A here, A is equal to, okay, maybe I will not use this one. So here, A is equal to the square root of 2 over 2 times your C, which is 20. Okay. So 20 divided by 2, so let me use another color. So 20 divided by 2, that is equal to 10, correct. A is equal to 10 and the square root of 2. So if we're going to find the measure of B, B is just equal with A. So A is equal to B. So B then is the same as A, which is 10 and the square root of 2. Well, I guess you can remember during your exam on how to solve the 45, 45, 90 special right triangle. Good luck and God bless. Thank you for watching. See you then.